Hello, so this is video number 2 of 3 videos on the fluid pressure lab for physics. So what I'll do in this video is just show and describe the apparatus to be used in the lab to collect data. And so you can treat this as a concept. I'm sure you would find other ways to create an apparatus that might work better, it might be more efficient in creating it, maybe less expensive. But so first what I'm going to do is I'll just show you how the apparatus is used, and then we'll take it apart and I'll describe each of the parts that were used to create it. So we have a large vase with water up to here, and then we have an object that will be floating in the vase. So this is just a glass cylinder with some weights in the cylinder that allow you to create a variety of weights for this cylinder, which is our floating object. And then what you'll do is and also you'll notice it has a metric tape taped to the side, which will allow you to take the measurement of how deep the object is floating in the cylinder. So we place the object in the cylinder, in the vase, and then you'll notice it floats, but it's at an angle. And you could make it work, you could try to figure out how deep it is, but what I've done instead is create a fixture to keep that floating object upright, and I'll describe this in more detail. So I'm going to place the fixture in there, and this will help to align the object so it's sitting vertical. Okay, so right there. So now it's floating. The fixture helps keep it aligned vertically, and then I can just visually read the metric tape. Right now it's at 17.5 centimeters. So that's how the fixture is used to collect data. Right now I have 3 individual weights in there, but I have others, so I could either take away or add weights to collect more data. Alright, so now what we'll do is we'll take this apart and describe the parts. So in our lab we are lucky to have the necessary machines to manufacture some of our own parts. So we have a small horizontal bandsaw, we have a drill press, we have a small tabletop Sherline milling machine, and then also a tabletop Sherline lathe. So we can manually produce a lot of the parts that I'm going to describe. So we can do the milling and the turning and drilling and tapping internal threads, cutting external threads. However, if you're not able to manufacture some of your parts, many of these parts can just be purchased, so you have alternatives. So we have our large vase holding water, and this came from Michael's Arts and Crafts. It seemed like they had a nice size there. They have a nice variety. This cost about $16, 12 inches high, 5 inches inside diameter. So that's a possibility for you. And then the object that's floating in the water it's actually called a hydrometer. It's a glass hydrometer. I found this on Amazon. It's used for for beer making and maple syrup making, things like that. So it's just a glass cylinder. It came with a plastic bottom, but for this lab we just take that off, and then it just has just a plain bottom to it. You can buy these hydrometers where the flange is actually part of the cylinder, and that won't work very well in this lab. So And then also attached to it is a metric tape adhesive. So this I just had this for other labs. It's a very long spool of adhesive metric tape graduated in centimeters and millimeters, so you can get a very accurate reading of the depth of the object. And then you can just cut it. It just keeps repeating itself, so you can just cut it with scissors and then just attach it to the side of the cylinder. All right, and then the fixture. So these were just some things I just had sitting in the lab. It was useful. This is just an aluminum base, which looks like 1.5 by 1.5 and about 3 inches. And we were able to clean this up on the milling machine. You might not need anything quite that large, but it's a good steady base. And then this rod is part of the alignment fixture, and we created external threads and internal threads, and it just screws in there. And this is a 3/8 inch diameter, 12-inch rod. You can buy them that length and that diameter. We get a lot of our materials from Online Metals. They can customize your order. Okay. So because you'll get corrosion with objects sitting in the water, aluminum's a good choice. All right, then we have the other part of the fixture is these rings, and the cylinder goes through the rings, and there's 2 of them, one down low and one up high. And let me describe the parts that go into that. So the white ring is just part of a PVC pipe. So you can just take a piece of 2-inch PVC pipe, 2-inch diameter, and I just cut this one up into, using a saw, just cut them up into rings that are 4/10 thick. And then there are 3 holes tapped and drilled. Let's see, we used 10-24 threads. So we have brass screws in the 3 tapped holes. And then they can be adjusted, so you can adjust them to help with the alignment of the glass cylinder. And then there's also a shaft collar that's used to attach to this rod. All right, so we have this ring with the brass screws that again are adjustable, and one of the brass screws you see is longer, attaches out to this shaft collar. When I first tried this, the set screw in the shaft collar rusted up, so we replaced them with stainless steel set screws. Now, we created the shaft collars ourselves here, but you can find these and buy them. So like here's an equivalent, here's a shaft collar that you can buy, but then you would have to create another tapped hole to fasten the ring. And I think you can get these made out of aluminum, because steel again would probably rust up in that water. Okay. All right, so then we have 2 of those, and that keeps the cylinder aligned. Now, what else we have going on here is the weights in the cylinder. So what we created was a hanger. So we have this hanger that goes inside the cylinder. So this is just a 12-inch long rod, an 1/8-inch diameter, and then we attached it to this aluminum cylinder that we made on our lathe. And then it just sits down inside of the cylinder like that, and that allows you to pull out whatever weights you have in there and then add more. So here are additional weights. They don't have to all be exact either, because you're always going to measure the weight of the cylinder before you put it in the water. So each of them has a hole in it, and you just slide the weight down over the rod. I've got 5 of them, but you could do more or less. Now there is an alternative. We made those here out of 1 1/4 inch round aluminum bar. We had, for other purposes, we still had some aluminum bar that we just chopped up with the bandsaw and then turned on the lathe. But what I also found, for those of you who do physics labs, I found a slotted mass. So here's a 50-gram slotted mass that's used for a variety of physics labs. This one, turns out that this is actually perfect size for this glass cylinder, and that fits on here too. So there's one that you could obtain where you don't have to do any fabrication. And these are about the right size too. These are 50-gram slotted masses, so they would work great. Okay, and I believe that's the whole fixture. Okay, so to wrap this up, just one correction I noticed. When I was describing the mass hanger and the weights, I described the rod on the mass hanger as an 1/8-inch diameter, but actually it's 3/16 diameter. Okay, so if you're interested, I have provided in the video description below, you'll see my email address. If you would like a bill of materials for this apparatus and also some details on the fabrication, feel free to send me an email and I'll send you back the file with those details. It'll be a Microsoft Word file. So there's one more video. Then the part 3 that'll come next is actually a video which will show the actual execution of the lab with students in terms of measurements and data collection and then the calculations. Okay, that's it.